and welcome to another video. In this video, we're going to talk about integration. Now, integration is simply the reverse of differentiation. Now, we know that when we differentiate, we're finding the rate of change, we're finding the gradient of the tangent, we're finding the gradient of the curve at a particular point, and so forth. Now, likewise, integration has real-life applications. However, we will explore those applications in another video. In this video, we're going to look at how we integrate these two problems. Alright? Now, if we have some function, f of x is equal to x to the n, then integrating this function, so integrating ax to the n with respect to x, so this symbol here, it almost looks like an elongated s. Now, this symbol here tells us that we are integrating. So integrating ax to the n with respect to x is simply this. So it's simply ax to the n plus 1 divided by n plus 1. And if you think about it, it makes sense. Because if we say that integration is the reverse of differentiation, with differentiation, we multiply by the power and subtract 1 from the new to get the new power, right? Subtract 1 from the power to get the new power. So to integrate, we add 1 to the power and then divide by the new power. Now this plus c here is very important, especially when we're talking about indefinite integrals. Now, this here is an indefinite integral. Alright? So once you don't see any number here, then we have an indefinite integral. And in that case, it is very important that you put here plus c. This c here is called a constant of integration. And its function is to represent any potential constant that we may have lost during differentiation. Alright, so this c here is very important. So, let's look at our problems. So we want to integrate 2x minus 5 divided by x squared plus the square root of x. Now, in order for us to apply this power rule here, we need to rewrite this guy here in a way that allows us to apply the power rule. Alright? So for 1, we're going to rewrite it as, so this 2x here is fine. So this is just 2x to the 1, right? Minus, so using our knowledge of indices, we can rewrite this as, so we say it again. So you bring it up, so the power changes to negative, right? So minus 5x to the negative 2 plus the square root of x is the same as, you got it, x to the half. X to the half. So now we're able to apply this rule. So what we have is, so since we're applying the rule, we no longer need to write the sign. Alright, so we're going to integrate now, and hence we no longer need this sign. So we have 2x to the, remember this is to the 1, so 1 plus 1, that's 2, and then we divide by the new power. Alright, so let me write it differently. So we have 1 plus 1 divided by 1 plus 1 minus 5x to the negative 2 plus 1 divided by negative 2 plus 1 plus x to the half plus 1 divided by a half plus 1, and put our plus c, or constant of integration. So what we have is 2x squared divided by 2 minus 5x to the negative 1 divided by negative 1 plus x to the 3 halves divided by 3 halves plus c. And we can simplify. So we have x squared, negative divided by negative, so plus 5x to the negative 1 plus, we're dividing by 3 halves, it's the same as multiplying by the reciprocal, so it's plus 2/3 x to the 3 halves plus c. And we could even go a bit further and say x squared plus 5 divided by x plus 2/3 x to the 3 halves. Or we could also say x, the square root of x cubed, but that is, we'll leave it here. So that would be our solution. Now, if you differentiated this, so if you were to differentiate this, then you would end up back with this. So go ahead and have a go. So differentiate this guy here and see if you end up back with the original thing. If you don't, then you did something wrong. Alright, so just have a go. Alright, so now we'll look at the second problem. So we want to integrate 3x plus 4 to the 5th power. And we're doing that with respect to x. So let's think about it. Remember, integration is the reverse of differentiation. So when integrating, you're undoing what you did when you differentiated. Now, if we were to differentiate, right, what we would do is we would bring down this guy here, right? So we multiply by this and subtract 1 from the power. So in keeping with what we were doing a while ago, what we need to do is add 1 to this power, so 3x plus 4. So we add 1, 5 plus 1, and divide by that same power. Good? Once again, if differentiating, we would differentiate in here. So we apply the chain rule. So we would differentiate in here, and we get 3. And then we would multiply by 3. But once again, because we're doing the opposite, we're going to divide by 3. So we divide by 3 plus c. So this gives us 3x plus 4 to the 6th power divided by 5 plus 1, 6, 6 3s 18 plus c. Now let's try differentiating this guy here and see if we end up back with this. So we want to differentiate 3x plus 4 to the 6 divided by 18 with respect to x. So using our chain rule, so we multiply by the power, so we have 6, 3x plus 4, we subtract 1 from the power, that gives us 5. Sorry, this was over 18. And then we differentiate in here, so that's 3, and we multiply by that. So 3, 6 is 18, the 18 should cancel, so we have, I left off the plus c, plus c, plus c. Differentiating the c, that's a constant, so that's 0, right? So we have that to be equal to, the 18's cancel, so we have 3x plus 4 to the 5th power, which is this. So there we have it. We did two good examples to introduce you to the idea of integration.